Okay, so the next step is a bit more advanced. Is how do we use conceptual masses, and we can use grids on those masses and use adaptive components and current wall patterns, etc., etc. So we definitely need a conceptual mass, and most of you have one already, so you can use the one you're using. I'm just going to do a very fast box option here. Something happened there. Wait a minute. Huh. Strange. I think it's the 3D snapping is on, no? Yeah, so the 3D snapping was on. I'm going to create a form here, and I'm just going to tilt one, for example, so we have an angle there, and I'm going to do a bit more irregular here. Okay, there we go. So one thing we can do with conceptual masses is, as you know, select the lines or the edges, but you can also select the faces independently, and you can subdivide. Okay, you press divide surface, you get this grid that automatically becomes transparent, has these blue lines. You can do that for any face or facade of your conceptual mass, and with that subdivision you can actually change the number of times those lines are repeated. Let's say like 5 times, so they change automatically. Let's say 50, just to exaggerate, and there you go. No, so this will be the UV famous subdivision. 20, 10, 10, etc. Nothing we can do from this grid is selected, and clicking here at the little arrow we can turn on nodes. These nodes are going to be important later on to apply directly. Is snapping to those nodes adaptive components. Okay, it's not yet the time to do that, but it will come soon. Okay, so the question is, how do we apply a new pattern base family into each of these grid elements? No, so there's actually a new family, and scrolling down at the generic models, we have several types. We're going to be dealing with adaptive models here, but we're also going to be dealing with pattern base. I'm going to do a very simple pattern base and a very simple adaptive, so you kind of get the idea of both with this tutorial. If you say new model pattern base open, this is how this new family works. Okay, this is, I'm just moving around the same way, scrolling and shift and center button to understand. You have like weird buttons that they have like vertical, horizontal, and planes, and they have a number on top. These points, those that have a number, those are called adaptive points. Okay, you can always make a point anywhere you want, select it and change it to adaptive. We're going to see that actually in a little second now. Now, what can we do with these patterns? Well, we see also a blue grid that relates directly to the blue grid from the conceptual masses, and if we select the grid here, we can see and expand the different types of grids that we have. Okay, so as you can see, you have different types, and we're using the rectangle one, a very simple one, but if you change it, it will automatically change the pattern to look as the ones that you have in front in the type options, hexagon, etc., etc. The most common one is rectangle, but you're welcome to defeat the laws of grid configurations and try other options. I must say that they tend to give errors, but it's good to try so we can resolve them in class. There's also this green thing that is difficult to see sometimes, and if I scroll on top, it shows like many like blue dash lines. Those are reference lines. We always have used reference planes, but not reference lines. Okay, reference lines are these ones that when you click and draw one, they look green, and when you select them, they actually have reference planes associated to the reference line. So they have a better coordination system of reference planes, both in the beginning point and the end point as reference planes, and along the line. As you can see, there's several reference planes. So they're going to be the main lines that we're going to use to define any component. Okay. As a very simple example, I'm just going to select the existing reference planes, which are 4. And this is the usual tool. As you know, you can create any kind of form after selecting lines. And it gives me 2 options. And I'm going to say square. Okay. And I'm going to save this. Let's imagine it's as simple as that. Okay. I'm going to go to the desktop and call it panel 1. You can even say save. Now we can load it into the project, and it's loaded automatically into our conceptual mask because I don't have a project open, otherwise you select it. And I'm selecting the grid, and look at the properties. We have the same exact system of types of grids, and under rectangle 1 we have panel 1. So if we select that option, it automatically embeds the panel we designed into each of these elements of the grid. Okay. So the question is, at this point, how can I make any kind of panel with any shape, and how we can apply it to that grid? No? So obviously we can change materiality here, like selecting the pattern, the panel, and we can change here the material. You can either click and search for materials here. I think you can also find other materials clicking on this option and selecting materials directly. Or the other option that I explained last class is creating a parameter. You can say, give me a parameter here, add a material and finish parameter like panel material. Say OK. So you can place that material later on in the project. Either way is fine. Again, you can actually select it directly and place in a material from the material library. Another thing we can do is, for example, select the top face and start thinking of the properties panel a bit more parametrically. There's one thing called positive offset here. We can click on this button and create another parameter that is dimensions parameter, and call it thickness panel. Say OK. OK. And you see how it's blurred out? That means there is a parameter. There's also an equal sign here. That means that I create a parameter that I can check on the family types and change it here directly. 3. And that would relate to the thickness of that panel. No? Okay, so if I load into the project, I can override the parameters. Just trying to think about it, and it changed that thickness. But you can also select directly the entire grid system and edit the type to search for the thickness panel here and say 3, and it will change it automatically. Okay. Another thing you can do is tab similarly to curtain walls and select one panel and actually change some of the parameters within that panel alone. No? Although this is under type, it will change all of them. No? If you want to change either to them, instead of a type, it has to be an instance. We'll talk about it later on. Good. So again, that's, I think, a simple, straightforward of creating a panel under the pattern-based family, and then loading into the project so we can repeat it. Obviously, if we come to the conceptual mass, we can change the UV configuration and say like 20 and 6, and automatically that pattern will adapt to the new UV configuration. No? There you go. Okay. So let me delete that and explain the basics of the adaptive components. Okay, I'm gonna again I could have done Control-C, but I just deleted the previous one and selecting the face. I'm gonna say divide. This is the same thing we did before, and I'm gonna just close the pattern. By the way, you should save these ones and take with you always. They're like XREF. And I'm gonna say Revit, New, Family, and I'm gonna select the other option that we're going to talk intensively about, Model Adaptives. Okay, I'm going to say Open, and it looks exactly the same as the conceptual mass. We know that we can create points, we can create lines the same way, but the only different things between the pattern-based family and the adaptive components family is that it has this point. By the way, you can click on points and create 4 points. Escape that, and at this moment they are actually regular points, but you can always select these points and say make adaptive. That will give you that famous number I was talking about and the 3 reference planes that create relationships between them. Now I can say reference line. I say 3D snapping, so there's a strong link between the line and the adaptive points, and I click to each of those points. Okay, I escape that because I'm done, and I select them and I create form. Okay, I'm going to save that. I'm going to call it panel 2, but this is going to be adaptive, and save, and I'm going to load it into the project. And here's how they come. By the way, if you don't see it for whatever reason, you can always go the same way as any other element, say component. And here's how adaptive components work. They don't apply directly to the entire grid. They want to know how you want to apply point by point in order your component. For that reason, it's very important that you create your component properly organized 1, 2, 3, 4 in terms of both the points generation and the line configuration. And then I cannot snap to these elements, and I'm going to skip that so I can select the grid, and I'm going to make it a little bit smaller right now. Let's say 5 and 10, and I'm going to turn on those nodes, clicking on the little arrow, and I can go to create component, and you will be able to snap to those points. So again, in order 1, 2, 3, and 4, and it creates one element associated to the nodes. Okay, so this seems like a ridiculous thing to do, but now I can select the component, and there's one option here under modify called repeat. Repeat, what we'll do is understand the grid, and it will just place them all together. No? So as you can see, we end up in a very, very similar point, but using 2 different interfaces. Okay, I'm going to talk more about adaptive components because I think I like them better, but we will deal with both at the same time. Okay. For example, if I'm in adaptive, I'm going to say Control-C. You can create another reference plane, 3D snapping, snap the diagonal. Okay, you can create a point in the middle of that new line. You can set a new line selecting the plane of that created point. You can do a reference line. Make sure you work on the draw and work plane and make it vertical. Okay, this point, sorry, I shouldn't have done 3D. So reference plane, no 3D in this case, and we want to do this point, and we snap vertically. We can create a parameter for the height of that line. Let's say vertical dimension. So that is going to be controlled by the new parameter here. Let's say 10, apply, and that changes in the back. Okay, and now what you can do is, for example, reference plane in an arc, saying 3D from this point. Sorry, we don't want to do that now. Reference plane here, that option, 3D, snap, snap, snap. Well, I was thinking more of an arc. Wait a minute. Reference arc, top 3D. Huh. Wait a minute. It's doing an issue here. What we need to do. Strange. Let me actually do this one then. 3D. Reference. Sorry, it's this option we want, don't we? 3D snap. Yeah, we're selecting the middle one, but it has to be at the end, the middle one. There we go. So we can make this line afterwards or before. Actually, I'm doing now at the end, and I can control that height, changing that arc configuration, like 15, and it changes. So now I can select these two, control this other one, and create a form to create a like this shape. And I could even leave it like that, or create another one here to have that kind of a shape. And you can assign materiality and just check that always your forms are following your parameters. That's good. And now you can just save it, obviously, and load into the project. You can override it. And you can have this parametric kind of a module. I could have closed this so it's more like a vinyl type of material or so. And obviously I can change the parameters of this by selecting editing the type and changing the parameter here to 50 to exaggerate. A little bit too much, no? Let's say 3. Okay. And again, you can close this one, just pressing here and control, create form, saving and loading, overriding, and you can have your quite interesting, more difficult to do otherwise, or almost impossible without this type of new family types. No, I'm not saying that you do this one, but it's I think a first nice lesson to take into consideration for adaptive components. Okay.